Hi everybody. Before we begin, please make sure to have your calculator out and have it be in degree mode. Please pause the video until you have this. Today we're going to talk about solving first degree trig equations. And before we can do that, we need to recall the exact value chart, which I've made here for you. We've made it plenty of times, no need for you to make it again. But I do want to review the unit circle. Now, just as a refresher, every point on the unit circle would be considered cosine theta, comma sine theta. So that means every x value would represent cosine and every y value would represent sine. So for example, if this is 0 degrees, I want to find cosine of 0 degrees. I look at the x value. So cosine of 0 is 1. What if I wanted to find cosine of 90? I would look at the x value. So cosine of 90 is 0. You look at the x value for cosine. What if I wanted to find sine of 0 degrees? I look at the y value. So sine of 0 is 0. What if I wanted to find sine of 90? I would look at the y value at 90. So sine of 90 is 1. I've made this whole entire chart for you to look at. You don't have to memorize the chart. You just need to know how to work the unit circle. Okay. Now let's recall one last thing. How do I find an angle given, say for example, sine of theta equals 0.987? The question is, how do I get theta by itself? Well, the way that we do that is we hit second sine. So sine -1. That will happen when you hit the second button. So grab your calculator, type in second sine, parentheses, 0.987, and hit enter. And I would like you to round this to the nearest degree. So what did you get? You should have gotten about 81. So your theta, or your angle measurement, is 81 degrees. Okay, how would we do number 2? Number 2, cosine of theta is equal to 0.5. So if I want to get theta by itself, I have to take the inverse of cosine. That's cos -1, or second cos. So do second cos, go ahead and plug that into your calculator, of 0.5. and hit enter. You should get 60. Please make sure your calculator is in degree mode, otherwise your answers will be different. Okay, how about example 3, cosecant theta? Cosecant is a sine sandwich, so this is 1 over sine, but I don't want to do this in terms of 1 over, so let's actually make it in terms of sine first. So let's make this sine of theta equals 1/2. Why did I do that? Because sine and cosecant are reciprocals. So if cosecant is 2, sine would be 1 over 2. Now this is much easier for us to deal with. How would I find theta? Do second sine, or the inverse of sine, of 1/2. So go ahead and plug that into the calculator, second sine of 1/2, and you get 30 degrees. Now, why did I have the purpose of the exact value chart if you could just do it in the calculator? I wanted to show you where it came from. So if you look, like the one we just did, second sine of 1/2, what value, what angle makes sine of that angle 1/2? 30 degrees. Look right up here, 30 degrees. Sine of 30 is 1/2. How about the one we did before? Cosine of what angle is 1/2? Cosine of 60 is 1/2. You know what I mean? So you can use the exact value chart if you prefer. Okay, we need to review reference angles. A reference angle is an acute angle formed by the terminal side of the angle, this would be the terminal side of the angle, the ending part, and the x-axis. This is the x-axis. So where is the angle formed by the terminal side and the x-axis? It would be this angle right in here. So this angle we'll call, 30 degrees. Now you don't have to write this down, this is just review. So all angles in quadrant 1 are reference angles. So all angles, this is abbreviation, in quadrant 1 are reference. Okay, how about in quadrant 2? What if I give you the reference angle and I want you to find the actual angle? So say this is 30 degrees. My question is, what is this angle? Well, we know that from here to here is 180. So what if I did 180 and subtracted off the reference angle? What do I get? 150 degrees. So I take the 180 and get rid of this piece. What am I left with? This piece. Therefore, this angle is 150 degrees. So what we need for this lesson is we're not going to actually find reference angles. We're going to find the actual angle. So let's find quadrant 3. So say the reference angle is 30 here. How would I find the entire angle, which is this, from the initial side to the terminal side? So do you agree from here to here is 180? Add 30 more. Okay, so 180 plus 30 would be 210. So that would be the measure of that angle. Okay, how about we find an angle in quadrant 3? What if the reference angle is 30? My question is, what is this whole piece? Well, we know that the whole circle is 360, and if we subtract off that 30, we get 330. Therefore, this angle up here is 330 degrees. Okay, one more thing to review. We have a sine curve and we have a cosine curve. If we look here in this equation, what's the amplitude? The amplitude is 1 because it's the number in front. So that's how high the sine curve goes. It goes 1 to -1. How about the cosine curve? The amplitude is 1, so how high am I going? 1 and -1. So would you agree all numbers greater than 1 are not in the domain, are not in the range of sine, and all values less than -1 are not in the range? Same thing here, same thing here. Okay, that will go into play a little later. Now let's go ahead and start solving. Okay, let's do example number 1. The steps are on top for you there, but you don't need them for right now. So it says solve each trigonometric equation to the nearest degree for all values within 0 to 360. So first thing, sine of theta is equal to rad 2 over 2. Okay, so the first thing we need to do is find theta. So again, like we did before, theta is equal to the inverse, so second sine, so sine -1, of rad 2 over 2. You can put this into the calculator, or you can just remember that sine of 45 is rad 2 over 2. So that makes theta 45 degrees. What did you just find? You just found a reference angle. Okay, so that means if we have the ASTC, all students take calc, that means that the 45 is an angle in quadrant 1. Now, if we look and focus our attention right up here, what do I know about sine of theta? It's a positive rad 2 over 2. So which quadrants do I need to be focused on? I need to be focused on quadrant 2, and I need to be focused on quadrant 1. We already have the angle in quadrant 1. It's a reference angle. So the answer for quadrant 1 is 45 degrees. What about the answer for quadrant 2? Well, again, we said we found the reference angle. So this is an angle in quadrant 2. So my reference angle is 45. How do I find the actual angle? 180 minus 45. So go ahead and type that into your calculator, 180 minus 45. So if you do that, in quadrant 2, the angle would be 180 minus 45, which is 135. So there are two answers here, 135 and 45 degrees. If you plug them into the calculator, you would plug in sine of 45 and get rad 2 over 2. You'd get sine of 135 and you'd also get rad 2 over 2. Okay, let's try another example. Let's try example number 2. So cosine of theta is equal to negative rad 3 over 2. So let's actually just do the ASTC right now. Cosine's negative, isn't it? So what quadrant should I be in? I should be in quadrant 2, and I should be in quadrant 3. So let's find theta. So theta would be found by taking the inverse, or second cos, of rad 3 over 2. I want to make a big stink about this. I'm never, ever, ever going to put the negative in here when I put it in the calculator. Never. The negative just tells you what quadrants we're in, and that is it. So when you are finding cos -1, you never, ever, ever want to put a negative. Okay, so if you did cos -1 of rad 3 over 2 in the calculator, or just looked at the exact value chart, the angle that you would get would be 30 degrees. So theta is equal to 30 degrees. That's a reference angle. That 30 is here. So again, if we have the angle ending in quadrant 2, this is 30. How do I find this? So for quadrant 2, it would be 180 minus 30, and you would get 150. How about in quadrant 3? So again, I'm going to erase this, which you can, but I'm just going to. And I'm going to say, what if the angle terminated in quadrant 3? Here's the reference angle of 30. I want to know what this whole angle would be. So again, you have to add 180 plus a little something extra. So plus this 30. So for quadrant 3, it would be 180 plus 30, which would be 210. Final answer. If you want to check it, type in cosine of 150 and see if you get this, and then type into the calculator cosine of 210 and see if you get negative rad 3 over 2. Perfect. Okay, let's try example number 3. Sine of theta is equal to a 2. It's equal to a positive 2 or negative 2? Positive. So A, S, T, C. What quadrant are we in? 2 or 1? How do I find theta? Theta is equal to the inverse sine of 2. So go ahead and put that into the calculator. What happened? You should have gotten error. There is an error because sine can't go up to 2. The amplitude was 1. Remember we just talked about that? Therefore, there is no solution to this problem. There's no value for theta that will make this true. Okay, example number 4. Cosine of theta equals 1. I want you to star this one, circle it, underline it, do whatever you need to do to recognize that this one is different. This one we're going to use the unit circle. So that's why I have a unit circle right down here for you. Okay? Unit circle. Anytime I've got either a 1, a negative 1, or a 0, you want to focus your attention here. So they're asking, at what angle theta is cosine, or the x value, equal to 1? I'll say that again. They're saying at what x value is cosine of theta equal to 1? So cosine of theta is equal to 1 here. So x is 1 here. Anywhere else? No, x is 0. X is negative 1. X is 0. X is only equal to 1 here. Therefore, the answer for theta would be 0, and theta would also be 360. The reason why I say never to use the calculator for these problems is go ahead and put in second cos, like say you were finding theta, you do cos negative 1 of 1. Go ahead and put that into the calculator, second cos of 1. You get 0. If you trust just the calculator, you're missing the 360. So do not use the calculator when you see 0 or 1. Okay, next problem. Number 5, tangent of theta equals 0. Now just to recall, tangent of theta is equal to sine over cosine, or y over x. So they want to know, when I divide y and x, which gives me 0? So let's look. 0 divided by 1. Yeah, that should give me 0, right? 0 over 1 is 0. How about up here? 1 over 0, undefined, no good. How about 0 over negative 1? That's good. That's give me 0. How about negative 1 over 0? No, undefined, no good. So where tangent is equal to 0 is actually at these two spots, here and here. And what are those angles? Those angles are 0, 360, and 180. Remember, this is 180, this is 0, and 360. So this problem has 3 different answers. Just for fun, put in second tan of 0 in the calculator. Second tan of 0, you get 0. You'd be missing the 360 and 180. So again, anytime the problem has 1 or 0 right here, you're going to use the unit circle. Okay, let's try example number 6. Cotangent of theta is equal to negative rad 3. So the first thing we want to do is ASTC. So where is cotangent, or in other words, tangent, negative? Not here, not here. So it's negative here and here. So that took care of the negative. We're never going to use the negative again. Now, how do I find theta? Well, we got to transfer this into tangent first. So do you agree that tangent of theta would be negative 1 over rad 3? Okay, so what else? Rationalize it. That should be familiar to you. It should be tangent of theta is equal to negative rad 3 over 3. So if I wanted to find theta, I would do second tan, or tan negative 1, of rad 3 over 3, or look at the chart, and you would recognize that that's 30 degrees. So 30 degrees is an angle here. I don't want that one. I want one here and I want one here. So again, if the reference angle was 30 degrees, what would this angle be? You're going to take 180, so for quadrant 2, we're going to take 180 and subtract 30. We get 150. Final answer. How about if the reference angle ended here? There's 30. I want this whole thing. That would be, for quadrant 4, that would be 360 minus 30. Final answer, 330. Both of those are your final answers. For homework, I would like you to try question number 7 and question number 9. For question number 9, you may have to get sine theta by itself, and we'll go over the rest in class. Thank you. Bye.